Hi everyone, today we are going to talk about Boyle's law. Okay, this is the first of many gas laws that we'll learn about. So first, a little background on pressure. Remember, pressure is force over area. This is our standard pressure units is going to be 1 atmosphere. We're going to usually use atmospheres, but you might see pressure in kilopascals, millimeters of mercury, torr, or pounds per square inch, PSI. Okay, barometers are the name of the device that measures pressure. And so they came up with 760 millimeters of mercury by putting some mercury and a vacuum tube here. And they saw that 1 atmosphere of pressure pushed the mercury up exactly 760 millimeters. So that's how we get that conversion. I'm going to show you some cool Boyle's Law demos now. Make sure you draw a model and explain what is happening in each of these demos. What's up everyone? Today we are going to be looking at Boyle's Law. And so we're going to learn about Boyle's Law by using this wonderful device here. I'm going to introduce you to her. Her name is Bertha. So Bertha is a really wonderful machine. She's actually a vacuum. So she'll be able to pull air out of this chamber and therefore reducing the pressure in there, and we can see how that affects the volume of various items in here. So we're going to learn Boyle's Law, and yeah, we're going to use Bertha here. So let's get to it. All right, this is demo 1, and we've got a bag of chips in the vacuum chamber here, and we are going to simulate what happens when you take this bag of chips up into the mountains. So as you may know, the mountains are at a higher elevation. So that means there's actually less pressure in the mountains. That's why they say the air is thinner. So let's see what happens when we reduce the pressure inside of this chamber. And there you have it. Hopefully you're able to see what happened to that bag of chips. If we look closely, we'll see that it did indeed inflate. All right, in our second demo, we're gonna take this balloon and put it under the same process. So again, I'm gonna use the vacuum to take away air particles in the chamber, therefore lowering the pressure. So let's see what effect it has on the volume of this balloon. All right, in the third demo here, I'm gonna do the opposite. I'm gonna actually let air back into the vacuum chamber to see what happens to the balloon. So here, we're actually increasing the pressure inside of the chamber. So let's see what happens to the volume of the balloon when we increase the pressure. I see the volume has decreased. This is the fourth demo, and we are going to take this warm water, which I just heat up in a microwave, and we are actually going to boil this warm water without applying any heat. So how do we do that? Remember that boiling occurs when the vapor pressure is able to overcome the atmospheric pressure that's pushing down on it. So what we're gonna do is we're gonna help it out by removing some of that atmospheric pressure. Okay, so let's see how this goes. there you have it. You see it boiling? All right, so we can tell it boiled because of all this steam that was produced. I'm going to let some air back in and check on the water here. So again, that water was just boiling, right? So it should be really hot. Oh, what? It's not boiling my hand. It feels fine to me. So there you have it. Boiling water without heating it up. All right, so as we saw, in Boyle's law, we're dealing with pressure and volume. So when pressure increases, volume decreases by the same amount. That's what we can see in this graph here. Okay, and vice versa. If we decrease the pressure, like using a vacuum, then we would see the volume increase. Okay, so these are inversely proportional, which means when one goes up, the other goes down. So if I double the pressure, the volume is halved. And we're going to use this equation, P1V1 equals P2V2, to solve Boyle's law problems. Let's take a look at one example problem now. So we're going to use that equation. A given sample of gas occupies 100 milliliters at 1 atmosphere of pressure. So right away, I'm given my V1 and my first pressure. Again, milliliters tells me its volume, ATM tells me its pressure. The pressure is increased, so now I've got a second pressure. What is the new volume? So I don't know V2. Okay, so again, I always like to list out all my variables. So V1 is 100 ml, P1 is 1 atmosphere. I've got my P2, which is 2 atmospheres, but I don't know my second volume. Okay, so I'm gonna now just plug it into our equation. P1V1 equals P2V2. P1 is 1 atmosphere. My first volume is 100 milliliters. And that's going to be equal to my new pressure, 2 atmospheres, times V2. I don't know what V2 is. To solve here, I'm just going to divide both sides by 2 atmospheres. ATMs cancel out, and I'm left with a final answer of 100 divided by 2, 50, and my units for volume are going to be milliliters. Okay. So follow those steps, rewatch this video if you need to, and that should help you with the Boyle's law practice problems.